Today I reassembled the laser. It didn't take long. It was just a matter of reversing everything we did when we took it apart. While that goes on in the background, a friend of mine suggested I give a little bit of an explanation of some of the things I talk about, as some people who are watching this might not have used a laser cutter before or had anything to do with building one. So a laser cutter is exactly what it says it is. It's a machine that cuts with a laser. It's quite simple. It's got a moving gantry that can move in the left, right, up and down directions, called the y-axis and the x-axis. Mounted onto this gantry are mirrors and a lens. The laser generally sits at the back, usually a big laser tube, either glass or metal box. It bounces via a mirror into the main part of the machine. It then bounces off the next mirror. This is on the one of the gantries, and then a second mirror, which is on the second gantry, down through a lens towards the bed of the cutter, which is where the laser beam is focused and cuts the material. Laser cutters generally cut wood. They can cut acrylic. This type of laser, which is called a CO2 laser, which uses intense infrared light, isn't particularly good at cutting metal. It can etch glass. It can etch rubber and leather and things like that. It's generally used in crafts or to cut out things out of wood and acrylic. The motors that move the gantry around are called stepper motors in most modern machines. These are electrically controlled motors controlled by a computer that can very, very precisely move in small steps, so they always know exactly where they are. So they're extremely precise at moving to position. So a computer can control them, and it can make the laser cut shapes out of wood, for example. This old laser here uses standard brushed motors, which is the sort of motor you'd get in most other things, like the back of your washing machine, for instance. Those type just apply a voltage and the motor turns. The way that this machine knows exactly where those motors are is, I believe, by monitoring the exact power going to it and the exact power flowing through it, I think. They're called brushed servo motors. Anyway, they're not the same as stepper motors. You can buy modern controllers to control them, but they're very expensive. So by far the cheapest thing for me was to take out the old controllers that control the motor, take out the motors themselves, replace those motors with modern stepper motors, replace the controllers with stepper motor controllers, and then replace the computer, the brains of the thing that is called the controller, with a modern controller. That way I can interface it to modern software, and it should work in exactly the same way. So I've put the machine back together and I boot it up, and this is where I run into my first problem. It's booted. I've no idea. Okay, so we can enter. Diode pointer. Can we turn that on? Is there a go? Reset. Oh! When I pressed focus, the bed moved. Has it got auto-focusing? And the screen is gone. Interesting. Has it died? Do we know what we're doing? We do not. I'm going to do a hard reset. Okay, it's booted the same as last time. It made the beep, which it usually then displays something on the display, but there's nothing on the display. I can't believe the display's suddenly just broken, right? So we get the startup sound, but we get no screen. Okay, we have no luck with the display, it's still blank. Let's have a look around this machine. There's some weird things I've noticed already. For a start, even though the display is blank, if I press reset, you'll see that the gantry does actually home. We have a connector down there. I think that might be for the rotary device. We have cable chain there, but on this side we have a ribbon cable. So I don't know if the ribbon cable powers the motor in here. I'd have thought it would take bigger cables than that because of the current it would be drawing, but I don't know. Let's open the lid. Let's turn the power off to make it a bit quieter. If we look down here in the corner, we've got a 15-pin D again. We should be able to move the gantry now. If we look down here, we seem to have two LEDs. Not sure why. Don't know why that has got a spring on it. This here is that the X-axis driver? So I'm hoping that those spacings are the same as stepper motor spacings and the spindle is the same as a stepper motor spindle. That would make things so much easier. However, there's not a lot of clearance there, so it might not work. I'd rather keep the original bracket, especially because of this. I don't want to put an inline stepper, it would mean a lot of metal cutting. So getting a stepper motor to fit in this space would be ideal. That might be a challenge though. We have the connector here for the ribbon cable for this gantry. I think the only way to see what's in the gantry is to take it off. Take the cover off, but before that, let's go underneath. We have the bed raise here, which is another big motor. That is the air assist input, I believe. I've noticed there's a slight wobble on the bed, but the bed is the runners are adjustable, so we can adjust those. If we look here, this is the laser head. We've got, I believe that's the air assist pipe. I think that other thing there is the focus. I don't know how the focus works, but apparently it's got full autofocus. That would be awesome if we could get it working with the new controller, but I'm not sure. Okay. Using a random piece of copper pipe to hold up the lid, let's see what's under this cover. Okay, that's a cute little thing. So it does look like all of the power comes in through those ribbon cables. I cannot see any other connection. It's obviously quite a tall motor. Is that... Okay, I'm not sure what kind of motor it is. It's probably brushed just like the rest of them. It's probably got a tachometer on it, I believe, rather than a rotary encoder. That's going to be interesting to replace with a stepper. That entire assembly looks like it is milled out of a solid piece of metal. So that could be a nightmare to replace. Maybe, if it doesn't need to be that high torque and it's a very light head, which it seems to be, it's an open frame head, we might be able to get a much smaller stepper in there. I guess we'll find out. Okay, I'm going to take some photos of this and do a bit of research. Let's remove the gantry cover to make sure there are no surprises waiting for us. Is that it? Ah, that's it. Wow, okay. So, interesting, right. Let's move this. We've got what looks like a linear rail on this side, just here. We have nothing on the other side. We've obviously got Oops, that's slightly movie. We've got a ribbon cable here, which is the focus, I guess. We've got this here, which I think is the air assist. That's very springy. And this, I think, is just to guide it. Okay. No idea how that focus works. It would be amazing if we could keep the focus, autofocus. But obviously with a new controller board, it might not be possible. That, I'm guessing, just is flattened by the cover. Okay. Let's get some photos of that. So I've been having a look around a bit more. This, as you can see, is the Y-axis motor, the thing that moves it forward and backwards or up and down, depending on how you're looking at it. It is, as we said before, a brushed servo, whatever that means. There are a couple of cables going in for power and a couple of cables coming out that somehow monitor the power usage or the speed or something like that, so it remembers where it is. This motor here is the one underneath. Looking this up, it looks like it's got a gear reduction ratio on it. So the motor can turn quite quickly and the belt turns slowly, which would make sense because you don't want the bed raising and lowering too quickly. Here we see that small motor that is the X-axis motor, the one that goes left and right. It is purely just a brushed motor. It's just got positive and negative feeding into it. So I'm not actually sure how the system knows where the head is in the X position. There are other circuit boards in this section. It just looks like the circuit board here is breaking out the wires for the motor, but they also go to the ribbon cable that goes across to the head and another circuit board slightly below it. So we'll have to figure out what that is at some point in the future. This is the actual head itself. As you can see, there's a little circuit board attached to the head that goes left and right, along with the head mirror and the head lens. This has got the ribbon cable attached to it. I believe this purely goes to the sensor, the depth sensor, the autofocus sensor, sorry. So a bit of research suggests that the autofocus sensor is nothing more than a depth sensor. The bed raises and touches the sensor underneath, and as soon as it touches, signal goes back to the computer to say it's touched. The computer must know exactly how far this sensor is away from the lens, for instance, and then it can move the bed to the correct position so that the focus point is correct for this type of laser. There is also another little sensor directly below this that seems to be either side of a thin piece of plastic that runs the whole length of the X gantry. Not sure what that does. Maybe that is the feedback for telling it exactly where the X position is. That's definitely something that we'll have to figure out. Here's a wider shot of the head. You can see the coiled air assist. The air assist literally just pumps air down a tube and the air points directly at where the laser's hitting. This is to blow away smoke and debris that it's burning as it's cutting. It vastly improves the cut and stops wood charring as much, for instance. This final picture is of the mirror and the lens. The mirror is on the top. The laser is coming across the X gantry at this point. Gets deflected downwards, and the lens you see on the bottom goes to the lens and it focuses. I believe this has a 50.4 millimeter focus. Is that 2-inch? Something like that. Which might make sense with the fact that I think the plunger is slightly less than that. So it would come down and reach the plunger, determine the length, back off a little bit, and that would be the focal length. Okay. So the next step, I think, might be to either take the motors and the mounts out so we can look at replacing them, or we can test fire the laser. I'll figure out what I'm going to do, and that will be my next video. Thanks for watching.